Good morning, this is Dr. Turner for Integrated Math 3. Today we're going over 7.5, which is looking at solving equation using the property of logarithms. There's a little bit of glitch on this lesson, unfortunately, so I'm going to go really quick through this. Just finished recording and it didn't save for some reason, so the work's already here, but we'll go through it and I'll show you what I'm talking about here in just a second. So when we're looking at solving equations involving logarithms, we are treating a logarithm as any other operation. So recall that we can, using properties of equality, if I add on both sides of an equation, it stays balanced. If I subtract, multiply, divide, power, root, any of those operations, as long as you're doing the same thing on both sides, it stays balanced. And that's the idea behind doing this with logarithms. A logarithm is a function, it's a property, and so if I take the same logarithm with the same base on both sides, then that equation stays balanced. In number 1 here, we had 2x equals 32. In a question like this, where I have 2 to some power, before in integrated math 1 and 2, we would have just tried to rewrite 32 as being 2 to some power. But instead of doing that now, because some of these will get more complicated, we're going to rewrite it as a logarithmic property. So I'm going to take log on both sides, and remember, by default, if I just have log for log, that's a base 10. And if I have natural log, ln, that's base e. So I would take logarithm on both sides. Using my power rule from 7.4, when I take logarithm and I have an exponent, I could take that x and move it to the front as I did here. By doing that, log 2, that's just a constant. That's some number, that's a value. So we're going to treat it like any other two-step equation. I'm going to divide both sides by log 2, which gives me log 32 over log 2, and I would evaluate that to get 5. You can use your calculator to double check this. Log 32 divided by log 2, which gives me 5. Okay. A couple things on this. One, when I take that logarithm and I'm treating it as a function, it doesn't matter what base I have. Right? If I took natural log, for instance, natural log of 32 over natural log 2, also going to give me 5. But if I'm not using decimals, if I'm just using a basic scientific calculator, it's not going to give me the option to change my base, which we'll talk about here in just a second. So typically your defaults are log, which is base 10, natural log, which is base e. Remember, e is that constant, and you can type that in. It gives you approximately 2.718, just like pi is approximately 3.14. Okay. Continuing on here, number 2, I have 4x minus 1 equals 50.